So with you guys' ACT coming up on Tuesday, make sure that you guys really, maybe take the weekend to do a little studying. Referring back to a lot of our worksheets even will really help your scores, okay? This unit is going to be so helpful for you guys on that ACT. So I really hope that you guys will really take it seriously. And then I bet if you do, that you'll have seen your scores come up if you've taken it at the beginning of the year to now. We've learned a lot. You have come so far. Okay, so remember everything we've learned so far in this unit. Not everything, but a lot of good things. So we know that a central angle starts from the center of the circle, works its way out. It equals its intercepted arc, right? So that angle will equal its intercepted arc. And then if we have an inscribed angle has to start on the circle and work its way out. So the two chords will work its way out, but it has to start on the circle. And that's called an inscribed angle. And we know that that angle will be half of its intercepted arc, right? So you take the arc length, divide it by 2. Or if you're given the angle, you'll multiply that angle by 2 to find the arc. And then we know that if we have a tangent line, what a tangent line means is it touches the circle in one spot. If we drop a radius from a tangent line, if you drop a radius down to the tangent line at the point of tangency, it will make a 90-degree angle, creating some right triangles and stuff, right, everybody? Okay, we've also learned that if you have tangent lines that come around a circle here, then you can know that a tangent line, if it intersects another tangent line out here, that those tangent lines will be equal in length, right? So those are equal in length, those are equal in length, those are equal in length, and those are equal in length. Right, everybody? Good review. And then also we talked about some chord lengths. So one of the theorems said, if we have two chords and they're equidistant from the center of the circle, we know they're equidistant from those red lines, right? If they're equidistant from the center of the circle, then the chord will equal the chord in length, right? Okay, and then we also learned if we have a diameter dropped and it's dropped at a 90-degree angle. Now we'll never assume, because we could drop it at a non-90-degree angle. Look, if I do it like this, we obviously know it's not 90 degrees, right? But if we have a diameter dropped at a 90-degree angle, then it will bisect the chord, meaning it will cut the chord into 2 even pieces. And it will bisect the arc. And we know that bisect means cuts into 2 equal segments. Okay, so today we're doing 7-6. We're going to be doing more with angle measurements and segment lengths when we're seeing different things. Okay, so first of all, this theorem is theorem 88. This is actually I actually have really never used this theorem until this worksheet. So what this theorem says, if you have an angle, so now the reason we get this theorem is because we want to still be able to find angles even if we don't have a central angle or an inscribed angle. So everybody look at this picture right here. Do you see how angle 1 is not an inscribed angle? This little thing does not touch down on the circle, right? So we can't use the inscribed angle theorem. And then also it's not a central angle because it's not starting at the center and working its way out. Does everybody see that? So we still want to be able to find the measure of that angle, and there is a theorem that will help us out. So it says the measure of an angle formed by 2 lines that intersect the inside of a circle. So we have these 2 lines that intersect inside the circle, and it creates this angle. It creates a couple angles, but we can find the angle by this formula. So the measure of angle 1 will be equal to half times arc length x plus arc length y. So I'm going to actually write that a little bit prettier. So I'll just call angle 1 theta. So theta will be equal to 1/2 times by arc 1. So let's just say I'm going to call it, so x plus y. So arc 1 plus arc 2. So guys, you're going to add up this arc plus this arc and divide it by 2, and that will equal that angle. Okay, so looking at this, here's our first example, and I ask you to find angle x. We say, okay, that's not a central angle, dang it, otherwise it'd be 90, right? It's not a central angle though. And then it's not an inscribed angle. So, but we do have 2 intercepted arcs on that angle. So we have this arc, and then we have this arc. So we know x will be equal to 1/2 times 90 plus 46. So you'll take your calculator. 90 plus 46, 136. So we have x is equal to 136 times by 1/2, which also means divided by 2. So x is 68 degrees. Everybody comfortable with that? Okay. Okay, so we're talking angles. So keep in mind that was finding an angle, and now we're going to still be talking about finding angles. Okay, so the measure of an angle formed by two lines that intersects the outside of a circle is this formula. So everybody, I'll just say it a little bit easier. So we have this angle. Now do you see how we have this line and this line that's making up this angle? Well, notice this angle is not inside the circle, right? Everybody? It doesn't start on the circle and work its way out. Otherwise, it'd be an inscribed angle. Well, this isn't an inscribed angle. It's an angle that's being formed on the outside of the circle. So same thing right here. We have an angle. We have two lines that form an angle on the outside of the circle. And then same thing here. We have an angle being formed from two lines on the outside of the circle. So the formula to find that is, first of all, realize a couple of things. Do you see how that angle intercepts technically two arcs here? See how it's intercepting that arc and that arc? Okay, and then this angle is intercepting this arc and this arc. So same idea, it's just drawn a little differently. And then looking at this angle intercepts this arc as well as this arc. Is everybody able to see that? Okay, so to find the measure of that angle, you'll take 1/2 and you'll subtract the big arc from the small arc. So the measure of that angle will be 1/2, just like before. But instead of adding up the two arcs, you'll take the big arc minus the little arc. Does that make sense? So you'll say, okay, we know that theta will be equal to 1/2, and then you'll take the big arc, so I'll say big minus small. Big arc minus small arc. Okay? And that will be equal to that. So here's my first example. If I say, what's angle Z? Once again, you say to yourself, okay, I'm finding an angle that is outside of the circle here. So we have a line that comes here and then touches down on the circle. So we do have this arc length, which is 95, and this is arc 20. Those are the two arcs that intercept that angle, right? So we know that angle will be equal to 1/2 times by the big arc, 95, minus the small arc, which is 20. So you'll take that in your calculator, 95 minus 20, then divided by 2, or multiplied by 1/2 is the same thing. So we get 37.5 degrees. So the difference, here's what you got to remember. This angle was on the outside of the circle, so it's subtraction, right? If it's on the inside, if the angle's on the inside of the circle, it's addition. So inside addition, outside subtraction. Okay, is everybody comfortable with that? It's the same formula, right? One's addition, one's subtraction. So the angle was inside the circle, therefore addition. The angle was on the outside of the circle, therefore subtraction. And we always do big minus the small. Okay, so let's find this, arc Z. So there's just going to be a couple examples today because it's going to take some algebra skills today. Okay, so looking at this one, I'm asking you to find Z. Now notice Z is actually arc Z, right? So you have to say to yourself, which theorem would I actually be using here? Well, don't we have an angle that's on the outside of a circle? So we'll be using the theorem, the theta is equal to 1/2 times the big arc minus the small arc, right? Now let's plug in what we know. So we know that theta is what? 20. We were given theta in this one. Is everybody comfortable with what I'm doing here? I'm plugging in what I know. So that's equal to 1/2 times the big arc, which is 95, minus the small arc, which is Z, right? And now isn't it just algebra to solve for Z? Okay, we've got to be able to do algebra correctly. So wouldn't we, well, there's many different ways of doing this. I personally am just going to go like this. So wouldn't we multiply both sides? Couldn't we, there's many different ways. Couldn't we multiply both sides by 2 to get rid of the 1/2? Okay, so I'm going to multiply both sides by 2. So we would have 40 is equal to, that divides out and becomes a 1. And then we have 95 minus Z. True? Yes. So now we'll take 40, we'll minus 95 from both sides. So 40 minus 95. So we have negative 55 is equal to negative Z, right? Now, to get Z alone, divide both sides by negative 1. So we get z is equal to 55 degrees. So we found the arc length of z, it's 55 degrees. Okay, so you'll have to use the theorem in whichever way works for you. Okay, so looking at this one, we're asked to find w here. So we're asked to find w. So first of all, what kind of theorem are we going to be using here? Well, aren't we given an angle that's made on the outside of the circle? So I just write that down automatically. So I know I'm going to be using theta is equal to 1/2 times the big arc minus the small arc. Let's plug in what we know. So we know that theta is what? 70 degrees. Is everybody comfortable with why theta is 70 degrees? That's the angle, right? It's equal to 1/2 times the big arc, which is... Isn't this the big arc, guys? From here to here? So W minus the small arc, which is this arc, right? I'll do different. Isn't this the small arc?
Yep.
So W minus 100. 110. And then it's just algebra from there. So once again, I'm going to multiply, right, both sides by 2. So I have 140 is equal to W minus 110, correct? And then we'll do add 110 to both sides. So when we have 250 is equal to W. And we're done, right? Yes.
Since you have 110 and that's like part of the circle, can't you just minus that from 360 and get it?
Oh yeah, that probably would have been easier.
Yeah, that's kind of a little like
Nice thinking. So we could check our answer by doing that, or we could have done it the easy way from the beginning. This is good practice, though. Awesome. Right, so Dylan was saying, okay, isn't this a circle? So wouldn't we just do 360 minus 110? That's the easy way, right? There are right ways and there are long ways. Depends on which one you tend to use. As long as you get the right answer. So that one would have been the smart way to do it. Okay? Okay, let's do this one. Okay, let's do this one. Guys, you need examples today. So some of you are like just zoning out. I mean, I can let you just go, but this was hard for me to do. So if it was hard for me, it's going to be hard for you. Okay? Okay, so looking at this one. First of all, which theorem are we using? We're going to use the adding one. This is an angle formed on the inside of the circle. So we know, and it's not a central angle, it's not an inscribed angle. So we say, okay, we know theta is equal to 1/2 times arc 1 plus arc 2, right? Everybody?
Yeah.
The big plus the small doesn't matter, right? Okay, so let's plug in what we know. We know theta is 35, right?
35.
So we have 35 is equal to 1/2 times 1 arc, 30, plus the other arc, x, right?
Yep.
So we'll multiply both sides by 2, right? So we have 70 is equal to 30 plus x, right?
Yep.
Minus 30. So 40 is equal to x. Questions? Couple more. Okay? I don't think we need to do this one. Do we? Okay, some people said yes, so this one will be quick. So first of all, what kind of angle are we looking at? An angle formed on the outside, right? So this is the theta is equal to 1/2 times the big arc minus the small arc. Let's put in what we know. Theta's y is equal to 1/2 times the big arc, which is 110, minus the small arc, which is 30, right? So we'll type it in 0.5 times 110 minus 30 in parentheses, 40. So our y is equal to 40 degrees. Is what? Okay. Okay. That one's the exact same, right? We're not going to do that one, okay? Okay, let's go through this one, okay? Let's go through this one. So first of all, a lot of times what happens is people look at the picture and they're like, I don't know where to start. So you got to look and see, where can I start? So first of all, I'll say, what do I have? So looking at y, isn't y an inscribed angle opening up on this arc? But we have no idea what the arc is, right? We do know that just this piece from here to here is 160, but we have no idea what that piece is, right? Right, everybody? Okay, so then we look and say, okay, but we do have these two lines making up an angle, right? And it's an angle that's being formed on the outside of a circle, which we just learned a theorem for. So we know that's going to be theta is equal to 1/2 times the big minus the small, right? To find one of these variables here. So put in what you know. Theta is 50 is equal to 1/2 times the big, which is 160 minus x, right? Is everybody comfortable with that? I can't tell. I'm kind of going fast. So then we'll have 100, because we multiply both sides by 2, is 160 minus x. Then when we subtract 160 from both sides. Negative 60 is equal to negative x. So x is equal to 60. Okay, so we know that x is 60. I'm going to put that in because I'm going to want to use it. Now, can we find this arc? Okay, 360 minus 160 minus 60, and we get 140. Well, if that's 140 degrees, and we have an inscribed angle, isn't an inscribed angle half of that amount? So it would be, what? 140 divided by 2, because that's an inscribed angle, so you get 70 degrees. Questions? Okay, this one's, I added it on there after I did the worksheet because I'm like, whoa, that was kind of hard without seeing an example. Took me a while to get it. Okay, so first of all, you're looking at the picture and you say, how, I'm solving for x how? Well, first of all, you say what kind of information I'm given. Well, I'm trying to help you guys think through how to think through it on your own. That's why I always talk out loud and say, like, so you're thinking to yourself, okay? Right? So you say to yourself, once again, what am I given here? Well, I have an angle that's made on the outside of a circle, right? So we know the theorem for that. It's theta is equal to 1/2 times the big arc minus the small arc, right? Everybody? Yeah. Okay, so first of all, this is x, right? This is, we don't know. And then this is 70. So let's put in what we do know. So we know 70 is equal to 1/2. And then we have our big arc. But we have no idea what the big arc is. We can't call it x, because then wouldn't you be saying that those two arcs are equal if they're both x? So let's think about how we could think this through. No, because you don't know that that's twice that amount, right? Well, then we'd have two unknowns. We'd have a BA and an x, right? So how is it solvable? It's not unsolvable.
It's impossible.
Just call it good.
Right, not enough information.
There is enough information.
Jackson has I have an idea.
Yeah, what's your idea? Help me out.
Well, I was thinking we could use two unknowns and then do like substitution.
So setting up two, I just don't know. I can't see what other equation. I mean, it's a good idea,
Let's try 614.
but there's. I mean, I don't see how where it's gonna go. What I'm thinking is, don't we know? Just I can't think with with you going. Just shut up and go on. Okay. So. I drew this example on it without thinking hard enough about it. So first of all, if we knew this and this, then we could somewhat go with it, right? Yeah. So, because otherwise we don't have enough information here right from here, because we have no idea what this is and what this is. But let's say, like I'm going to make this up on the spot, so kind of, let's cross our fingers. Let's say I said that this was 40 and this was 40, okay? Let's say that. Is everybody comfortable with that? Yeah. Now, wouldn't this arc be technically 360, the total circle, minus 40 minus 40, right? So 360 minus this amount minus x. That's what we're going to do. Okay, so let's combine what we can in here. Does everybody see why I set it up that way? Why that arc is equal to that? Okay, so now we have a true statement we can go off of. So we know that this arc is 360 minus 40 minus 40, which is 280, right? Minus x, right? So now we can do our problem. Are we all comfortable with that? You're going to have to do one like this. Okay, so we know that our big arc is 280 minus x, right? Minus our small arc, which is x. Does everybody see how I set it up? Yes.
You just have to assume it's 40?
On our paper, it doesn't give us the.
No. Yeah, but your paper's lines go on the outside. So wouldn't it be 360 minus x?
Oh.
So I would have had to give you enough information on the picture. Okay, so continuing this, so we have 70 is equal to 1/2 times 280 minus 2x, right? Because negative x minus x is negative 2x, right? Yep. People? So now we're solving for x. So we would do 70 times 2, which is 140, which is equal to 280 minus 2x. So then we would take 140 minus 280. We have negative 140 is equal to negative 2x. Then when we divide both sides by negative 2. So x is equal to 70. Okay. All right. Ready, set, go. These things, we just saw these things. We saw this angle that was not a central angle nor an inscribed angle made, right? We just learned how to find angles and then arcs, right? With something like this, an angle made on the inside of the circle. And then we saw this where we have an angle made on the outside of the circle. We just learned how to find angles and arc lengths. So now we're going to be talking about segment lengths. So there's some theorems that go hand in hand with these type of circles. So now not only find angles and arcs, but to find segment lengths. Okay, so you'll want to write these theorems down. I have to refer back to them here and there as well. Okay, so here's a few different cases. So first of all, if we have an angle made on the inside of the circle, and we don't have a central angle or an inscribed angle, so something like this, then you can find missing segment lengths by knowing this theorem. A times B will be equal to C times D. Okay, so if you have only one unknown, you'll just plug in what you know and then solve. So once again, A times B will be equal to C times D. Now that's if the angle is formed on the inside of the circle. Does everybody understand that? So that would be to find missing segment lengths, meaning physical lengths of lines. Okay, and then if we have an angle made on the outside of the circle and you're missing a segment length. So we have some lengths here. We have this length, we have this length, and this length. We have 4 segments here, kind of. Technically 2, but we're splitting this one into 2 segments and this one into 2 segments. Okay, this is what's true. W plus X times W will be equal to Y plus Z times Y. Now that one's a little bit easier. Somewhat. It's kind of hard because you're like, well, how am I going to remember that? So this is how I say it in my head. Outside, do you see how that's outside the circle? So this will help you kind of not have to memorize all these little things. Okay? So everybody, hopefully this will help. So do you see how this is the outside portion of the segment? So we do outside plus inside times by the outside. Okay? Outside plus inside times by the outside will equal outside plus inside times the outside. So that's easier for me to remember than having to remember W plus X is W, you know what I mean, everybody. Do you get what I'm saying? Do I need to say that again, the little thing I just did? Okay, so everybody watch so that you can understand what I'm saying. So the formula goes, the outside plus the inside times by the outside will equal the outside plus the inside times by the outside. Okay, so outside plus inside times the outside. That's all you got to remember. Does that make sense, everybody? Okay. Now, here's the catch, though. If you have a chord, so this was a chord and a chord. Now, if you have a chord and a tangent line, does everybody see how this is a tangent line? It's only touching the circle in one spot. Then the formula is a little different. You'll do this. The outside plus the inside times the outside will equal the outside squared. So we'll equal the outside squared. So that's why it's y plus z times y will equal t squared. So I'll give you a second to get those down. Okay, I'm not going to give you a whole lot of problems, so just stay with me. You need the example so that you can really fully understand, guys. I'm not going to assign very many more after this, like a couple more, okay? So just stay with me. So first of all, looking at this picture, we're solving for y. Say to yourself, what kind of theorem am I looking at? Well, first of all, we have an angle made on the outside of the circle. I'm trying to help you guys see how to think through this, especially when you get to something like the test review, okay? So we have an angle formed on the outside of the circle. Now, we're finding segment length, right? So you know that that's going to be the formula. Well, first of all, because these are two chords, one's not a tangent line, right? So we know that the formula is the outside, so I'm just going to start plugging it in. 6 plus the inside. Outside plus the inside times by the outside. Does everybody see how I wrote that? That will equal the outside plus the inside. So that would be 7 plus y times by the outside. Now we're solving for y algebraically. So we can do this many different ways. So I'm just going to add these up. So we have 6 plus 8 times by 6 is 84. So we have 84 is equal to. There's many different ways of going about solving for this. I'm just going to, I guess, distribute in 7. So that's 49 plus 7y. There's other algebraic ways of solving for y. Now to get y along, we'll do 84 minus 49. You get 35 is equal to 7y. Because I subtracted 49 from both sides, right? Divide by 7, so y is equal to 5. Questions? Okay, let's do this one. Okay, stay with me. Here we go. So you say to yourself, okay, I have an angle formed here on the outside of the circle, and I'm looking for segment length. So I know there's two different formulas. Do we have a tangent line or do we not?
Yes.
Yes, so the formula is the outside plus the inside times by the outside will equal the outside squared.
Yep.
Comfortable with that?
Oh, yeah.
Now we're just solving for z, so I'm just going to add that up. So we have 8 plus 16 and then times by 8. That's 192 is equal to z squared. To solve for z, won't we just take the square root of both sides?
Yep.
And then technically we would put a plus and minus, right?
Yes.
But a minus answer won't matter in this problem, so we throw out the minus answer. Take your calculator. The square root of 192 is 13.9. We're down to 1 decimal place. There's our z.
Holy cow.
Questions? I'm not going to assign a whole lot of problems, so stay with me through the examples, okay? Okay, looking at this one. Same thing, right? So we're finding segment length. It's an angle formed on the outside of the circle. So we have 14, the outside plus the inside, times by the outside will equal outside plus the inside times by the outside, good fix. And then we have plus, which is equal to the outside plus the inside times by the outside. Now I don't need to go through and solve algebraically for that one with you guys, right?
No.
Setting all the problems is the hard part. Okay, let's look at this one. So you could continue algebraically to solve that one. So then from here, do we have an angle on the outside of the circle? No, right? This is an angle formed on the inside of the circle. So finding segment length with this one would be what? 6.5 times 3. A times B equals C times B. So 6.5 times 3 will be equal to, oh wait. Oh, this picture is kind of hard. It's not gauged very good. So this 3 is actually this length. Sorry. It's really hard to tell in this picture. This 3 is actually this length. My fault. This M is right here. This is M. Okay, so we'll actually be doing, 6.5 times M, right?
Yep.
Will be equal to 3 times 7. So now it's just algebra. So you'll do 3, so we have 6.5 M is equal to 21, right? So 21 divided by 6.5 is 3.2. So M is equal to 3.2. Questions on that? Okay, let's do this one. So is this, okay, so with this picture, we have an angle being formed on the outside of a circle, right? And it's segment length on the outside of the circle. So, we wouldn't be using the A times B equals C times D. We'd be using the other one, right? So let's solve. Wait, no, that doesn't work for this one. This isn't an angle formed on the inside of a circle. Right?
No.
Oh, what are you saying? Sorry? Oh, I see what you're doing. Yeah, that's a good way of doing it. So you're saying...
Does that work?
trying to think. I'm drawing a blank.
You have to do your 2 chord first, and then your 10. Your 15, your 7, your X, and your 5.
7 is equal to. Okay, I'm seeing it. Sorry, the picture's kind of deceiving. That's 5. Is everybody good with that?
Yeah.
So yeah, let's focus on this one. That's what you were saying, Riley. Yeah, Riley. I'm like, wait, I get Tyler and Riley confused. Okay, so let's focus on this segment here. So we'll be doing 7 plus 15 times the outside, right? Is equal to the outside
5 plus
5, and then plus x, right? 5 plus x
times 5.
times 5. So let's solve that one really quick. Go, help me out. So we have 154 is equal to 25 plus 5x, right?
Yep.
So we have 154 minus 25 divided by 5. So we have x is equal to 25.8. So that's 25.8. And now we'll solve for y. So looking at this, we have an angle formed on the outside of the circle. I'm going to draw it out. Don't we have a chord and a tangent?
Yep.
So we would be doing 5, the outside, plus the inside, which is 25.8, right? Times by the outside, which is 5, will be equal to y squared, right? Everybody? 5 plus 25.8.
Plus 26.
So 134 is equal to y squared, right?
Yeah, 11.
Yeah. I think it's 30.
Yeah,
20, sorry, I think I typed it in wrong. So 154. I have 154 is equal to y squared. Square root it, you get y is equal to, what did you say?
12.4.
12.4. Okay, awesome. Okay, so there's like a lot of people not listening, so you guys must know how to do it. So I guess I'll just let you finish up now. These are what are required. So if you know what you're doing, which apparently most of you do, don't need these